So the last part of section 38 is graphing, and it has to do with these transformations. So what's happening here with this replacement function? So f of x, it could be any function. So whether it's the absolute value, whether we have an exponential, if we have a logarithmic, if we have a parabola, a cubic, any type of function that we have, it's the exact same sort of transformations that are taking place. And it's all based on the value of k. So k is going to be a number. So k equals some number. And whatever k is, we're going to apply the transformation. So we have some sort of effect that's happening to the graph. I like to talk about how when we have plus k, and that I like to refer to it as being outside or it's away from the function. So it's outside or away from it. Okay, so for vertical translation, so if you think about a vertical line, you're either moving up or you're moving down. So if we're moving up, that's because k was positive, or it said plus. If we're moving down, that's because we were subtracting k, so it's a subtraction sign, or negative. So a negative k. So we're moving up or we're moving down. Horizontal translations. So horizontal lines, you think they're left and right, okay, straight across. So we're going to be moving left and right. These are always inside or right next to that x, not the function, the x. So I like to say next to. All right. This is a little bit funky. It's going to be the opposite of the way that you're thinking. So whenever we have a plus sign, we're actually moving to the left, and whenever we have a subtraction sign, we're actually moving to the right. So if k is plus, I'm going left however many number. If there's a subtraction sign, we're moving right however many number. After that, we have k, and it's going to be right in front of the entire function. So notice that it's multiplied and then by whatever that function is. So when we have that right in front of the function, what you're going to do is you're going to multiply only your y by k. So you're like, all right, I don't know what y is. So for all of these, for everything, anything that we do, you always have an ordered pair. So what you do is you write down the original ordered pair, and because we're transforming this, we're translating it to vertical stretch or compression, you're taking whatever y is from the original, and you're going to multiply it by k. So you're going to do y times k. And that's how you get your new ordered pair. You'll see like it says compression, all right, or we have vertical stretch or vertical stretch. So you can refer to the inequalities to figure out if it's a stretch or compression. They write right here, but all you have to know is be able to multiply y by k. So you just have to know how to change the ordered pair. And then finally, we have horizontal stretch and compression. So notice that k is directly next to x. So what would this look like? We would have f of like 2x plus 7 something, something, something. All right, the 2 is talking about that vertical stretch or compression because 2 is right next to it. So what you're going to be doing is you're going to take your ordered pair, the original ordered pair, and you're going to multiply x by 1 over k. And then, of course, you could follow like the actual rules over here for what it means to write down the word stretch or to write down the word compress, right? But what you have to know is just be able to multiply your x by 1 over k. So for all of these, we just take our original ordered pair, whatever x is, you're going to multiply by 1 over k. And k is a number. All right. So when given, so this is called a parent function. All right, that's our original function. It looks like either that or that. All right, they're the exact same thing. We have the absolute value of x. So everything is based off of that. Every sort of translation is based off of a parent function. Okay. So you'll see that we have three different things happening for numbers 11, 12, and 13. So for these next three problems. So notice that for my parent function, we're starting at 0, 0, and then we have the same slope on the right, and then we have, so like on the slope on the right, it's positive 1 or 1 over 1. The slope on the left is negative 1 over 1, right? So we're still using 1. One's positive, one's negative, but notice that the entire right side is reflective on the left side. So the right side reflects to the left side. Whatever's on the right is the exact same on the left. They're directly like spaced apart from one another perfectly, okay? And that happens with every single absolute value. So we're going to take a look at number 11, and we have f of x equals the absolute value of x, and then we have minus 2. So that minus 2 right here, notice that it's on the outside of the absolute value, what I like to call the outside. So you're going to go back to your chart and you're going to say, okay, it's on the outside. Well, it's a vertical translation. I'm either moving up or I'm moving down. Because we have a subtracting 2, we're going to be moving down 2. So what I'm going to do is I'm going to start at 0, 0, and we're just going to move down 2. And we're going to plot our point. And then I'm just going to pick 2, 2 next. So I'm going to go to 2, 2, and I'm going to go down 2. I'm going to count down 2. And I'm going to plot my point. You can go to 3, 3 next, and then go down 2, right? And then you're at 3, 1. I like to go, I just like to go up by 2s. So 4, 4. And then I'm going to go down 2, count 2, go down 2. We have our new coordinate. You'll see that the pattern, right? You might see a pattern, which is perfect. So then you can label all the other points, and then we can go ahead and draw a line. Now, whatever's on the right side is exactly reflected on the left side. So they're spaced out perfectly. We can go ahead and draw our line. So this is my graph of the absolute value of x, and then minus 2. In number 12, we have the absolute value of x plus 3, closed absolute value. So notice that this is inside, or it's next to x, right? It's next to the x. So we're looking at that plus 3. That plus 3, that's k, all right? It's next to the x. So when it's next to or inside of with the x, that's when we're moving left and right, and that's when we're thinking the opposite of what we want to do. Because it's plus 3, I'm going to be moving left 3. Plus 3, we're moving left 3. So I'm going to go to my parent function, and I'm going to be moving to the left, count 1, 2, 3. And then I can go to like 2, 2, and I'm going to count 1, 2, 3 to the left. And I can go like 4, 4. You can pick anything. 4, 4, and go to the left 3. And then once you see that pattern, continue on the exact same way that you were before. Now, whatever the right side is, the left side is going to be the reflection of it. So you can go ahead and see that pattern of graph of points, and we can go ahead and draw it out. So we move left 3. So we refer back to that chart every time. Since you're new at this, keep referring back to that chart. All right, number 13. For number 13, what I'm going to do is I'm going to multiply the number 2. We're going to multiply y by 2. All right, we're multiplying by y by 2. So I'm going to take in a coordinate from the original parent function. So my original coordinate. So I can put numbers like 0, 0, 2, 2 as an original coordinate. 4. 4 was an original coordinate, and what we're going to do is we're going to be multiplying just the y, that's my rule, just y by the number 2. So we're multiplying this, and this by 2. So when we do that, we end up at 0, 0, right? We have 2 times 2 to get 4, so we're at 2 comma 4. And we have 4 times 2, which is 8, so we're at 4 comma 8. So we can go ahead and plot these points. Now you didn't have to pick the ordered pairs that I picked. You could have picked like 1, 1, or 3, 3, or 5, 5, 6, 6. So that's the right-hand side of my graph. The left-hand side is a reflection. And there's my graph at number 9. All right, number 14. So there's a couple things happening in this number 14. 2 things are happening. The first thing that is happening is we're moving, right? This is right next to the x. It's on the inside, it's right next to the x. So therefore, we're going to the right 3. And then that plus 2, that's on the outside. And that means that I'm moving up 2. So you're going to look at your parent function. All right, we started at 0, 0. And you're going to the right 3, and then you're going up 2. So my starting point is right here at 3, 2. From there, go ahead and create the next several points. All right, you might have to pause the video, but here's our graph for number 14. All right, then we have number 15. So again, there's a lot happening in this next problem. Lots going on here. 3 things. The first thing that's happening is this 1/2 is out in front, which means that we need to multiply y by 1/2. Then we have this plus 2 that's inside, all right? It's inside and next to the x. All right, so therefore we're going to the left 2, and then we have this minus 4 that's on the outside, so we're going down 4. So what you're going to start by doing is write down the first ordered pair that you see of the parent function. I started at 0, 0. Then I like to do 2, 2, and then we can do 4, 4. All right, so what you're going to do first, because you're like, do I move left 2? Do I move down 4? What do I do first? The first thing you're going to do is multiply the y by 1/2. So first you're going to multiply y by 1/2, and then you're going to translate it left 2, down 4. I'm going to do 0, 0 with together with you guys. So we do 0 times 1/2. So we're at 0, comma 0. And then we're going to go left 2, down 4. So this is where my graph is going to start. Right, at a certain point, you should start to figure out the pattern of what the slope is, and then you're able to create the other points and go ahead and graph it.